Today is the 4th June 2026. I'm doing another practice of overcoming my hesitations and fears of making videos for YouTube, trying to get just more comfortable doing these things. I'm doing another one of my random bag topics. So let's see what I will pull out today. Put it away. What do we have? What fun do I have these days? Alright, it seems I get the fun ones now in all in a row. So, I mean, that fits me. So what fun do I have these days? That's what a coincidence. I just thought about talking about that. So what fun do I have these days? I'm currently mostly having fun with just doing a little bit more programming. I'm back at programming Voxel Engines. That's just one of the things over... How long am I doing this now? Way over 10 years. Like at this point, 15 years, something around that I'm programming Voxel Engines. I really like just working on Voxel Engines because in some ways they push you to limits, because it's very easy with a Voxel Engine to just run to the limit of a computer, and you have to be very careful about how you optimize them, and you really have to optimize Voxel Engines or they won't really run well and can't scale up in any meaningful way. So that's just a very fun challenge. It's also just a very abstract and in a way simple but also complicated work, because when working with Voxel Engines, mostly it's just working with 3D grids and then you have meshing and all of that stuff around, but it's very much just very poor data-based work. It's just working with integers or other data type, or just raw data in some grids that you don't even probably store in just like necessarily a 3D grid. Currently, my current Voxel engine is basically just 3D textures. I'm going back to working with just like full RGBA data at this point, because I intend to use it more for maybe doing an editor or something like that, and more using it creatively and not having it so much as a runtime high performance engine. And yeah, that's also just something that I very much enjoy about Voxel Engines. It's because they are so demanding when it comes to optimization. Like it's like my current one voxel for me, for example, takes up 1 byte. One voxel for me is 1 byte, and that means even like in a basic chunk, how you know them from voxels, which is 16 by 16 by 16, which are 4096 voxels. That times 4 byte means already I'm at 16 kilobytes on data. If I go a little bigger, if I just do like kind of even a small data of 265 by 256, we are at 16 million voxels. Times 4 means, well, I'm already at 67 megabytes of data that I would just have in the RAM, and just operating on that also means I have to operate on 16 megabytes of data, which at this point is not that much, but we are also just talking about 256 by 256 by 256 voxels, which, depending on how you want to use voxels, is not that much. So, and I mean, 4 bytes per voxel is actually quite a lot. Most of the time I work with 2, so like 16 bits is like my default. How I work with voxels. 1 is oftentimes enough, to be honest. Going lower is actually a little bit difficult. I mean, you could, and I never did just like solids, but then you don't have any like of texturing or stuff like that. That would be a little bit boring. I'm not sure if it would be smart to go lower than 1 byte for a voxel. Potentially, depending on what someone wants to do. But because you just run very quickly into just very raw performance issues and very raw memory and optimization issues, Voxel engines are just, for me, very intriguing. There are so many approaches that you can have to such a simple thing of just 3D grids at this point, because voxel engines at the end of the day are not really much else than just a 3D grid with some very raw data in them. Again, a voxel is just 4 bytes. And depending on what you want to use them for, first, very specific, for specific contexts, there are not a lot of voxel engines. I think you should, ideally, very perfectly done. There are not a lot of voxel engines you should use for very specific cases. The more specific your cases, the less choices you have with a voxel engine, because there are just a few, because everything in a voxel engine is like an insane trade-off. Yours, do you want to optimize for using the least memory, having the fastest meshing times or something like that? Do you want to be able to just iterate over voxels a lot and change them a lot? Like what's the thing that you want to optimize for, depending on what you want to prioritize and what you need more and what you want to optimize on. The approach is actually quite different. But at the end of the day, it's all just 3D grids of very simple data. And for me, that's just very interesting. And I don't know, voxel engines, they just draw me in. And right now, I'm like completely immersed in writing voxel engines and working on them kind of full day, most of the time, pretty much. It's difficult to get away from them. So they just really draw me in and get me in a completely flow state. And it's just nice. It's kind of why I'm doing it. I don't know where this will go. If that will just be another voxel engine that I will also just throw away, but I just have fun with them. I mean, you probably can see from how excited I even talk about it. Voxel engines for me they're just so simple and still fascinating and intricating and fascinating things for me. There's something on them that draws me to them. I just love working on voxel engines. That's where my fun currently mostly comes from. I really like working on voxel engines currently, and I'm working in Godot right now. I made the switch in like the last year from Unity to Godot. And so first I tried in GDScript commute-based meshing, naive and greedy mesher for just some basic texture 3D voxel data. And I mean, with that, I had like performances for, I think it was for 16 by 16 by 16 voxel chunk. I got like around, I think 6-7 milliseconds meshing time with the GPU. Most of the, I think like 2 to 3 or 4 milliseconds. So like kind of 40% of the time was just the converting the data from the buffer, not even reading it, but just data processing on the GDScript side to just create the mesh object. So like 40% of that was just GDScript overhead for iterating over the vertices and converting them into the formats that Godot for the meshes wants. So I lost a lot of performance there. So converting that approach with like the commutator very much directly one-to-one to C++ to a GD extension, which I'm now more in. Converting that actually didn't really increase the speed. I think I got down to like 4 milliseconds. So I basically just cut the time of the GDScript processing down. So commutators for voxel chunks, reading them back takes a lot of time. So it's just mostly like the communication between the CPU and the GPU that takes a lot of time. That's kind of annoying. So can't really use. That was the first time I really tried commutator. In like the last decade, I always just did it on the CPU. My last one in Unity was very heavily with the job system, and very heavily parallelized on the CPU, which in a job system actually worked performance-wise. I mean, not with too small grids, but with like decent voxel object size. So when you're around over 16 by 16 by 16, with the job system Unity, you actually get a little bit more performance out of the parallelization from the job system, because it's just so highly optimized than with like pure for loops and just iterating over data. And now I'm doing it in C++, where mostly just normal loops and just doing some small slice optimizations and memory copying where possible, but mostly just normal single-threaded loops, for loops over the voxel data is what I'm now doing with C++ and the cheat extension Godot. It's a long time ago that I've written a voxel engine in C++, and to be honest, I wouldn't have liked to write a voxel engine C++ currently without AI. Like, I really dislike C++. I've used on many uses dependent, but I've looked into and I've worked like on at least small projects with pretty much any major and even not that major programming language that's really out there. Like, there are just a few very, very niches ones that I haven't looked at and I haven't put at least a little bit my fingers on. So over the decades, I even wrote voxel engines in pretty much all languages and pretty much all kind of rendering frameworks that you have, from C, C++, in Rust, in Python, in Java, which was probably my biggest language, and in Kotlin, and in Nimlang and stuff like that. So even like very languages that most people don't really know. I'm not sure if I've written one in Go. I haven't done that much in Go and stuff like that. But I've used a lot of language. I've written one in Rust and stuff like that. I'm not sure if I've written one in PHP, but PHP was not really for voxel engine, but I also worked a lot with PHP. So, but I have to say, from all of the languages that I worked with, I mean, there are one that's, of course, I also don't really like. I never really got into Haskell and that stuff. I even like Clojure more than I like C++, which it says something. Like, I really dislike C++. I think it's such an ugly language. And yeah, I leave it at that. Let's not go into programming languages. This talk was about fun. I have a lot of fun these days. I'm doing great currently, mostly because I work on voxel engines. So let's end this so I can just get back to doing some more programming on voxel engine. All right, have a nice day.